Now, we worked on code that allows us to emit an event when we create a new post. Now, obviously, we're not just creating posts, we're also updating or deleting posts. We want to be able to handle that too. Now, let's do that together and let's continue with updating posts. So on the backend of the feed controller, I'll scroll down to the update post method. And in there, we want to emit an event once we're done updating. So towards the end, once we got our result, we save the post and we're sending a response. Here, I'll again use IO, get IO to get access to our established IO connection, you could say. And I'll again emit on this posts channel, and I'll emit my data, just as before. Now I will keep my pattern of having an action where I this time write update, because this is the action where you performed. And my post is then my result here, because result turns out to be the result of my saving operation. Now, just as before, I want to be sure that I also have some user data in there. So we'll actually scroll up where we find that post, and I will populate it with my creator data. This again will take that creator ID, which we stored in the post object, reach out to the user's database or the user's collection, fetch the data for that specific user, and add it here in our post. Now I do emit this event where I send my created post. And let's now go back to our frontend application here and also establish some code here to update our post. For this, after this add post function, I'll add a new function, which I'll name update post, where I again get my post data and then I do something with that in the arrow function. And as before, I prepared some code, which we just copy in there, which will add or which will update the post in our list of posts. Now also scroll down in your React code here in the same file to the finish edit handler, because there, where I also have some logic to edit the post, here I will get rid of that. I will actually get rid of this entire part here and also of my update post assignment in this return statement in the set state call, because I now no longer update it here, but I do emit the event to all connected clients, including the client who did, sent that update, and therefore I can also set up my listener and use that with this new update post function I copied in up there. So let me now go up, and here where I have my established listener for the posts event, I'll add an else if block to see if the action maybe is update if it's not create, in which case I'll call this update post and pass data.post to that. Now before this will work, let me go back to the server-side code, and there, since I do populate my creator when finding that post in the update post function here, this check here will actually fail, where I do check if the ID, which is now not the ID anymore, but the full creator object, is equal to the request user ID. So here, I actually want to access creator._ID toString, right? Because we're populating the creator field with the full user data. It's not just the ID anymore. So we would fail editing this post if we don't make this change. And now if we save both, and we go back and reload both pages, I deleted one post in the meantime, so I only got two anymore. And let me now edit this a cup post here, add a couple of exclamation marks maybe, and click accept. And you see it added or being changed on both clients. So this is now also working. So now we also manage updating via Socket.io. There's one tiny thing you might be wondering about. If we create a new post, like a duck again, where I add the image and some content, it does show up at the top, but once I reload, it's actually at the bottom of the list. Well, this is simply due to how I sort on the backend. When I get all posts here in Feed.js controller, get posts, there we simply have to sort by created at date in a descending way. And now by doing that, if I reload on the front end, our latest posts come first there too. So that's just some tiny cosmetics which better align with the rest of our application, of course. It doesn't affect the way we use Socket.io though, of course. We're now using Socket.io to successfully update and create posts. Now let's of course also align the deletion of posts. And for that, let's first of all go back to the backend code, to the feed controller, and find our delete post method here. There it is. Now, just as before, I want to emit an event once we're done deleting. So I will do that right before I send my response here, let's say. I will use IO, get IO to get that connection, and then I will emit to the posts channel, and I will keep my pattern of defining what happened to my posts inside of the data package I'm emitting. So in here I'll add my action, which I'll name delete, or where I have a value of delete, I should say. And then my post field here is just the post ID, written like that, which in this delete post function I am extracting up there. So I'm passing that ID through that event I'm now emitting through Socket.io. That is what happens on the backend. Now let's move on to the front end, to the React code, of course. And there, just as before, we want to do something when we deleted a post, and I'll keep it simple. I'll simply reload the page here. You could, of course, implement some code here that simply finds that post, that changed, and just deletes it, but I'll keep it relatively simple and just load the entire page. If we scroll down a little bit to the delete post handler here, we can therefore also comment out this code and instead just call this load posts to reload, not the page, but reload the posts, essentially. This will make sure that pagination also is considered correctly. And now if I scroll up again to component.mount, where I have my other listeners for Socket.io, I'll check if the data action might be delete, which is the latest action we're emitting on the server. And then I will just call this load posts to basically load all posts again. Now this is my front-end code, and now if I go back to my application and I do delete another duck here, it reloads and it also reloaded the posts on the other page, as you see. So now we're also orchestrating deletion to happen across multiple clients through Socket.io. So in this module, we had a closer look at Socket.io, and I hope it became clear what you can do with it. You can push information from the server to the client through that emit method provided by Socket.io. And I also mentioned that Socket.io is not the only way of implementing WebSockets, because behind the scenes, it's that WebSockets protocol that allows you to push data from the server to a connected client. Socket.io just makes using that WebSocket protocol, that technology, particularly easy, and therefore it's a very popular package. Definitely dive into the official docs of Socket.io to learn all about the different features it offers and what you can do with it, because it's a very powerful library, gives you a lot of cool features. So definitely check out the official docs to learn more about it. And of course, also have a look at the other implementations you might be able to use. I just want you to be aware that WebSockets are something that build up on HTTP. You establish them, as you'd see in our application, as a HTTP handshake. So you need a running HTTP server, either set up with just Node.js or a package like Express. And you then use that server to establish a socket, a WebSocket connection on top of that. So both run simultaneously, and as you see in our example app, we actually got both going on. We got normal requests, so to say, and we take advantage of Socket.io as well. So this is an exciting piece of technology that might be interesting for your next application too, and I hope that this module provided a nice introduction to it. Welcome to this module. The best things always come at the end. In this module, I want to dive into an exciting piece of technology with you. We'll dive into GraphQL, an alternative to building a RESTful API that you would use in the same scenarios. So when you have a decoupled frontend and backend, you will not render views with a GraphQL API too, but it provides some significant advantages over REST APIs, at least in certain scenarios. So in this module, we'll explore what GraphQL actually is and how it compares to REST APIs. And you will learn how to use GraphQL, of course. We'll actually take our existing project and turn it into a GraphQL API or use a GraphQL API. A very exciting technology. I'm super excited to get started with it, so let's dive in. Now, what is GraphQL? To really explain it, let's compare it to a REST API, which we already learned about. A REST API is a stateless, client-independent API for exchanging data. So it's a Node Express application, or Node with any framework application, of course, that we build to exchange data. We don't render views, we don't store sessions, we don't care about the client, we only get requests, parse the data, and return responses with data, typically JSON data. A GraphQL API is generally not that different. It's also a stateless client-independent API for exchanging data, but, and that is the important part, of course, with higher query flexibility. And to understand that, let's have a look at some REST API limitations. Let's say in our REST API, we have an endpoint that looks like that. We can send a GET request to /post, and as you might imagine, this would fetch us a post, let's say from the database, but could also be from a file or anything like that, of course. And this is how a post might look like. Now, we return that to the client and everyone is happy. But what if we actually only need the title and ID on the client? What if we don't need the content or we don't need the creator data? We can, of course, have many scenarios where we use one and the same endpoint in our front-end application, so in our single-page application or our mobile application. And in one place, on one page, we might need title and content. On the other page, we might need content and creator. How can we solve that? Well, solution one is, of course, to simply create more endpoints that return the different types of data. We can create a new REST API endpoint, for example, sending a GET request to post-slim to only return title and ID. Now, obviously, by the way, you could also, of course, use the same endpoint all the time and just parse or filter out the data you need on the front end, but then you're sending a lot of unnecessary data over the wire, which is an issue, especially when working with mobile devices. So, our solution could be to simply create more endpoints that simply return the data you need for each of these endpoints. The problem is, you'll have a lot of endpoints and you'll have to update them continuously, and you also have a very unflexible solution here. If your front-end engineers, and in bigger projects you typically work in different teams, if they need more data on a new page, they come to you as a back-end developer and ask you to give them an endpoint that returns that data. And they're stuck in their front-end development until you added this. So fast iteration on the front end is made harder. And on the other hand, you on the back end continuously have to add new endpoints to cater for the needs of your front end engineers. So this is not really ideal. Solution 2 could be to use query parameters. On your existing endpoints, you could accept query parameters like data equals slim. Now, obviously, that is an option, but just as with the first solution, you always have to add it so that your front-end engineers can continue, and you have this dependency between front-end and back-end. Additionally, your API might become pretty hard to understand because it might not be clear which query parameters can I set, which values can I set on these query parameters. So this is also not ideal. Ideal for apps where you often have different data requirements on different pages is to use GraphQL. There, you don't have the problems I described before, because there, as you will learn, you have a rich query language that you use in your front end to send it to the backend, which is then parsed on the backend and dynamically retrieves just the data you need. So it's almost like a database query language, which you use on the backend, like SQL or MongoDB query language, almost like something like this for the front end, so which you put into the request you send to the backend. Now, that is the idea, but how does GraphQL work then? Well, we got our client, we got our server, and on the server you generally have your logic for interacting with the database, with files, anything like that. Now, what do you send from client to server? In a GraphQL world, you only send one kind of request, and that is a POST request to GraphQL/GraphQL. So you only have one single endpoint where you send your HTTP requests to, even for getting data. And why is that? Well, for a POST request, you can add a request body, and that request body will contain that query expression. GraphQL defines its own query language, and I will show you where to learn more throughout this module, of course. And you use that query language, you put it into the request body, and you just can't send request bodies on GET requests, for example. So you put your query language expression into that request body, and that will be parsed on the server to then do some magic on it and return you just the data you want. That is the idea behind GraphQL. Now, such a GraphQL query would typically look something like this. It's a JSON object-like structure where you have an operation type. Query would be for getting data. You also have other types like mutation for editing or deleting or inserting data, or subscriptions for setting up real-time data subscriptions using WebSockets. You also have the endpoints, you could call them, or the commands you can execute, and you define them as a developer on your backend, the available endpoints. And then the fields you want to extract. And that is the flexible part, because you could, in one place, get the user with just a name, and in another place, you could get name, age, and email. So that is exactly what you put into your query, which you send to your backend, which is then parsed there. Now, regarding these three operation types, as I mentioned, we got a query. There, we retrieve data, and we use a POST request for that. But if we want to compare it to the REST API world, then this would be your equivalent to sending a GET request to some path there. We also got mutations, which basically are used for everything that changes data. So what you previously handled with POST, PUT, patch, and delete requests. And subscriptions, as I mentioned, set up real-time connections via WebSockets. We'll not focus on that in this module because this is no GraphQL course. And indeed, you can create whole courses on GraphQL. Here, I want to focus on the core features. So to sum it up, in a big picture, we have our client. We send a request to that single GraphQL endpoint on our server. And then there, and this is the part you will do with me in this module, there you set up your definitions for queries, mutations, and possibly also subscriptions. In these definitions, you use type definitions because GraphQL uses a typed query language, which means you define the types of data you work with, the types of data you return in a query, and so on. And these endpoints you define here, so these queries and mutations and subscriptions you define, these are connected to so-called resolvers, which are functions that contain your server-side logic. And if you compare that to a REST API, the definitions would be your routes and the resolvers would be your controllers. And that is how you can look at GraphQL, and this is how we will implement it. So to sum it up, it's a normal Node and possibly Express server. Of course, you're also not limited to using Express.js. You're also not limited to using Node, by the way. The GraphQL language or approach can be used with any programming language, just as REST APIs could. But this is a Node course, of course, so we'll focus on that. You have one single endpoint, typically /GraphQL, though you could change this, of course. You only use POST requests because you put that query expression into the request body. And you have resolvers on the server side that analyze that request body and then do something with your data based on the query expression you had in that body. And we'll use third-party packages for that parsing and so on. So posting for getting data, that is the most confusing thing you typically have when diving into GraphQL. Yes, this is what we do. This is what is okay here because we describe the data we want to get in the request body. Now that was a lot of theory. Let's see it in action. To see it in action, I'm back in our REST API project we created earlier, where we previously added Socket.io. And first of all,